Okay, so we have three more formulas that you have to know from this section. So from section 7.3, we have the sum of difference identities, and then on Friday we talked about the double angle formulas. Now today we have the half angle formulas, which again are just about memorization, which is exciting, right? They actually give some formulas in here, like where these come from, but I'm not even going to show you those. I'm just going to give you this, right? Unless you want to see the proof. Anybody want to see the proof? No, you don't. Quit pretending. So, sine of v over 2 equals plus or minus the square root of 1 minus cosine v all divided by 2. That's exciting, right? Cosine of v over 2 equals plus or minus the square root of 1 plus cosine v all divided by 2. And then the tangent one should make sense because tangent is sine over cosine. So tangent is plus or minus the square root of 1 minus cosine v over 1 plus cosine v. Because if you put those two over each other, that would be what you would get. Why does it have plus or minus? Because it depends on what quadrant you're in, right? Depending on what quadrant you're in, if it's positive quadrant for that sine, cosine, or tangent, you would take the positive one. If it's negative, you would take the negative one. And so we're going to practice a couple versions of these, and then that's it, right? It's pretty short notes. It's just memorizing how to do them. So, ready? Ready. Find the exact values for sine of 22.5 degrees and cosine of 112.5 degrees. The idea is sine of 22.5 degrees, think about the formula I just gave you. Sine of v over 2 equals plus or minus the square root of 1 minus cosine v over 2. So when they give me 22.5 to find, what is v actually? Right, it's 45. This is already the half of it. V is like, v over 2 would equal 22.5 degrees. So to figure out what v is, you're going to double that angle every time. Does that make sense? So 22.5 degrees, I don't know what that is, but if you double that and think about this as sine of 45 degrees divided by 2, you do know what the sine of 45 degrees is, so you can do this problem. But you just have to think through on how to do that. And every time you'll just double that angle. So think about 22.5 degrees. Is that going to be the positive root or the negative root? Yeah, because 22.5 degrees is in quadrant 1, and in quadrant 1 sine is positive. So I'm going to take the positive root of 1 minus cosine of 45 degrees, all divided by 2. And what is the cosine of 45 degrees? 1 minus square root 2 over 2 all over 2. Think I want you to leave your answer like that? No. What do you want to do? We could do the common denominator at the top. What? Multiply by 1/2. That would work too at the same time. However you want to do it, we're going to get the same answer. So I'll do it both ways, all right? So you can kind of decide what you want. If we got a common denominator on top, that would be 2 minus the square root of 2 all over 2. And then dividing by 2 is the same as multiplying by 1/2. Do you agree with that? If that works. So could I say 2 minus the square root of 2 all over 4? Or square root of 2 minus the square root of 2, and technically we could take that square root of 4 of the bottom, which would just give me 2. That's really, really ugly, right? There's a square root in a square root, but that's about as good as it gets for us, which means that would be the answer, which means if you take the sine of 22.5 on your calculator, it's going to be really ugly decimal. You could type this in your calculator and see if it's the same ugly decimal, to get that. Jake suggested multiplying by 1/2 on the top and the bottom. Would we get the same answer if we did that? We would get, oh, then we'd have a half here. And then you could, well, it'd be, I don't think it makes it any easier, right? On the bottom you get 1, and up here you'd get a half minus radical 2 over 4, and then you could get a common denominator, and it would still work out the same way. I think, yeah, you'd get the same answer. I feel like that way better. But I think the book leaves the answer like that. Square root of 2 minus square root of 2 all over 2. Barf. Let's do one more with numbers. Aaron, stop biting your nails. If they ask me to find 112.5 degrees, if I double 112.5, does that equal something I know? What's 12 and a half? 225. Is that a multiple of 45 degrees? I think it is, isn't it? Yeah. It's like halfway in quadrant 3. So I'm going to double page this. Actually, add a page and then a double page. All right. So if I'm going to find the cosine of 112.5 degrees, if I double that, that's like cosine of 225 divided by 2. So again, let's think for a minute. 112 and a half degrees. That's in quadrant 2. 225 is in quadrant 3, right? So we're really taking half of it. But luckily, either way, for cosine, it's negative, right? Quadrant 2 and quadrant 3. But you really look at this angle of what quadrant is. 112 degrees is in quadrant 2, and in quadrant 2, cosine is negative. So that's how I know to give the negative root. Does that make sense on whether to give the positive or negative? You have to think about where you are. And then for cosine, it's 1 plus cosine of that doubled angle, which would be 225 all over 2. And then again, it becomes simplifying again. So is that going to be 1 plus the square root of 2 over 2? Which is going to be very similar to that other answer over there. Do you agree with that? It almost is testing your algebra skills as much as it's testing your trig skills on this. Negative, should that be negative square root of 2 over 2? So I'm going to change that to minus square root of 2 over 2. Which means it's going to be the exact same answer except for a negative out front. Do you agree with that? So I could say 2 minus square root of 2 over 2. Wait, that should be all over 2. All over 2. Or that would be 2 minus square root of 2 all over 2 times 1 over 2. So that would be square root of 2 minus root 2 all over 2 outside the root. Which is the exact same answer of sine of 22 and a half. And the reason that those are the same, except for it's a negative out front, is they're the same reference angles, right? Like it's a 45-degree angle. That's why it worked out the same. But if it would have been something that would have been half of like 30 degrees or 60 degrees. How did I get this? Yeah. I just got the common denominator. So like that becomes 2 over 2 minus root 2 over 2, right? Okay, and so then that all becomes over 2. I didn't do a very good job of writing that. What I've seen on the quizzes and tests that I've looked at isn't as much as this as it is the stuff like you do with the double angles, where they're going to give you one and they're going to want you to draw it out and then apply it to this. So let's see if we can do some of those. Whoa, that's gigantic. Like this lovely question. It says, if tangent of alpha is negative 4/3 and alpha is in quadrant 4, find, why does it just say alpha over 2? I think that should say find tangent of alpha over 2. Sorry. So again, this kind of puts you back at drawing the triangle more than using your unit circle. They tell us we're in quadrant 4. So again, you can draw a lovely picture here. If I called that, oh, I guess I should call that alpha. Tangent is opposite over adjacent. And in quadrant 4, do you agree that the 4 would have to be negative and the 3 would be positive? Which means it's still my good old 3, 4, 5 triangle, right? Which means I don't have to deal with ugly radical stuff right now. And then I can use this triangle to find the rest of this. So find tangent of alpha over 2. That's saying, do I know the value of it? So tangent of alpha over 2 is going to equal plus or minus the square root of 1 minus cosine of alpha over 1 plus cosine of alpha. I don't know.
I heard it's probably people
Yeah, I don't know. So do you agree using this triangle, we would say cosine of alpha is just going to be 3/5? Sorry. There's just other formulas in your book. Remember how cosine of 2 theta, they gave you 3 formulas? There's 3 formulas for tangent of alpha over 2. So I was trying to see where they were getting that from. But let's see if we can get the answer from this, and then if not, we'll see maybe why we should use the other formula they gave me, I guess. I don't know. What did I say here? 1 minus 3/5 over 1 plus 3/5. The issue with this is a radical, right? And so since we're going to get a number out of this, maybe we can simplify it.
Which is it? Is it negative on that side?
Why do you think it's negative?
We're in quadrant 4, right?
We're in quadrant 4 for alpha, but what about alpha over 2? If I'm in quadrant 4 and I divide an angle in quadrant 4 in half, where would I end up? Do you agree with that?
Like the whole,
Like every angle in between here is going to be between 270 and 360. So think about if you took half of that, right? Half of this and half of this.
Yeah, I guess that would be. Sort of.
We're trying to figure out if our outside number should be positive or negative. All right? And the other problem that was easy to tell because you just looked at the angle. Where was the angle? We don't know what alpha is. We just know that alpha is in quadrant 4. So I said if we're in quadrant 4 and we took half of any angle in quadrant 4, would we always end up in quadrant 2? And it's really easy to tell. If you think, like, you have to be bigger than 270 to be in quadrant 4, yes? If you take half of 270, you get 135 degrees. If you take half of 360, what do you get? 180. And really, it's going to be bigger than 135, but less than 180 would be half of any angle in quadrant 4. So I agree with Aaron in saying that you have to be in quadrant 2. Because based on that I'm in quadrant 4, I'd have to be in quadrant 2. Is tangent positive or negative in quadrant 2? Negative, which is why we can say there's a negative out here.
Take 4, take 45 by 2.
Right, I don't know if that works with the odd ones. 1 minus 3/5 would be 2/5, yes? And 1 plus 3/5 would be 8/5. Let's see if this works, kids. I would get 2/5 times 5/8. Or that would be the same as saying 1/4. And what is the square root of 1/4? And it's going to be negative 1/2 because we decided we're in quadrant 2. Just in case you want to know this, there are 2 alternate forms of tangent of v over 2 based on the fact that we can substitute in, we can multiply and simplify. You could say tangent v over 2, you get rid of the radical, that's why people like this, is 1 minus cosine of v over sine of v. Or that's the same as saying sine of v over 1 plus cosine of v. And they're getting that by multiplying by the conjugates, because you're going to end up with 1 minus sine squared, 1 minus cosine squared, or 1 plus cosine squared. Yeah, because you're going to end up with sine squared. Hold on, and I'll work one out for you. I don't care which one you work out, which one you do, because notice by using the one that we started with, we still got the same answer. You get the same answer using those. It's just whichever one seems easiest for you to do would work that out. So what was the original one that we wrote out? We said it was the square root of 1 minus cosine v over 1 plus cosine v, right? If you multiply the top and the bottom by, what are they multiplying by? Just by the radical, maybe? So let's do, you don't have to write this down, but here's kind of the proof of this, okay? What time did we get out of here? Too soon? Property of radicals, I can break those up. So what if I multiply the top by 1 plus cosine v? On the bottom, if I take a square root times itself, do you agree I would just get 1 plus cosine v? Yes, because the square roots cancel each other out. On the top, they don't cancel each other out. So you have to keep the radical, but these are difference of 2 squares, right? Which means if I FOIL that out, I'm going to get 1 minus cosine squared. Yes? And what is 1 minus cosine squared? So it's the square root of sine squared. And what is the square root of sine squared going to be? So that's where the radical went. How do they get this one? They multiply the top and the bottom by the square root of 1 minus cosine v. So that's where those come from. I don't care which one you use. The book used one of these because it was just easier than dealing with the radical. But we got the same answer using the radical, so I don't care which one you use on there. Tomorrow, we're going to review all the formulas you need to know. I'm going to give you a few problems to do. But the big thing on your quiz, like your quiz is like one question with like 4 parts where you have to know the addition rule, the subtraction rule, the double angle rule, the half angle rule for those trig functions. And so the big thing for the quiz on Wednesday is that you memorize these rules. So Jake and I will work on making a Quizlet in 5th hour to maybe study tomorrow and figure out how you can do that. Your homework is just 5 through 8, and then 9B is the only one I'm making you do on 9, because there's parts like A, B, and C. So not bad to do, but you need to get caught up on your homework if you're not caught up. I will check homework on Wednesday, and we will take a quiz on Wednesday. Whether we have 2 hour delays or not will be the plan.